Well, hi there, boys and girls. We're going to start our polar unit, and there's two things I want you to get out of this video. There's two things I want you to be able to do. One of those things is I want you to be able to plot points in polar coordinates. So I want you to be able to draw those points. And I also want you to be able to convert between polar to rectangular. So I'm just going to do P for polar and R for rectangular, and I want you to be able to go backwards too, so we'll do vice versa, also rectangular to polar. So let's take a look, first of all, is how to plot points. Now, rectangular coordinates are the ones that you're used to, x comma y. But polar coordinates are in the form r comma theta, where r stands for the radius, or the distance from what we're going to call the pole. So instead of the origin, I'm going to use the name pole for the origin. So let's take a look at this picture here. I've got a bunch of radial lines that represent angles. Here's the radial line that represents pi over 3, radial line for 4 pi over 3, and I've got circles, these concentric circles. They all share the common center, and so these concentric circles are intersected by these radial lines. And so let me show you how to find this. This would be, 4 would be r, and the 5 pi over 3 would be your theta, because they're in the form r comma theta. Now what that means is you're going to go to the fourth circle and find 5 pi over 3. And you can do this in either order. You could also go to 5 pi over 3 and then go to the fourth circle. So let's take a look at that. 5 pi over 3, well, is labeled right here. So you're starting with 0 and we start rotating around to 5 pi over 3, which, by the way, is 300 degrees. So you rotate around 300 degrees. And then you count out and you go to the fourth circle. So we rotate around and we've located the radial line 5 pi over 3. There it is. So from the pole, I'm going to count out 1, 2, 3, 4. There is the ordered pair 4 comma 5 pi over 3. So that's r comma theta. That's a 3. So let's do the next one, and we're supposed to call that point P. The next one, point Q, 3 comma 7 pi over 6. 3 is your r, 7 pi over 6 is your theta. 7 pi over 6 is 210 degrees, and we can see if we rotate around, it's right here, and we go to the third circle from the pole. 1, 2, 3. There we are, and that's point Q. All right, now a negative radius. The negative radius, let me show you what this means. I'm going to go to 5 pi over 4, which is not labeled here, but 5 pi over 4 is 225 degrees. So it's the 45 degree angle in the third quadrant. So it's right there. It's 225. And so I'm going to rotate around to this radial line that would represent 5 pi over 4. That's this one right here. Now, negative means you're going to go back through the pole and go the opposite direction. So instead of going to the second circle here, I'm going to go backwards and get right here. This would represent negative 2 comma 5 pi over 4. And this is our first introduction into the fact that these names are not unique. What I mean by that is I could have labeled r as positive 2 comma just pi over 4, because this angle right here is pi over 4. So there are an infinite number of names for polar coordinates. So let's do one more. Here I've got an r of 1 and a negative pi over 3. Now a negative angle means you rotate clockwise. So negative pi over 3 is coterminal with 5 pi over 3. So I'll go there and go to the first circle and I'll put it right there, and there's our S. Alright, so now let's talk about converting. Okay, now we have learned some things in parametric modes. We know in parametric mode, sorry, I'm a little stuffy. We know that if we have a triangle, I'll draw one right here, and I'll draw a line straight up to it there. And that if there's an angle here, and we're going to call that theta, the x coordinate is x, the x component is x, the y component is y, and we're going to call the radius r. And that's the Pythagorean Theorem, and also some trig equations are true here. So let's look at cosine theta. Cosine theta is adjacent over hypotenuse. So that means if we solve this for x by multiplying both sides by r, we get that x equals r cosine theta. We already knew that, but that's also true in polar. And sine of theta is y over r, opposite over hypotenuse, so y equals r sine theta. These are your conversion formulas. Now tangent of theta equals opposite over adjacent. That means y over x. So that means that theta is going to equal the arc tangent of y over x. And of course the Pythagorean theorem holds here in a right triangle, so x squared plus y squared equals r squared. So r is the square root of x squared plus y squared. I'm going to put a plus or minus here because r's can also be negative. So let's do a conversion. Let's convert to rectangular coordinates 4, 5 pi over 6. So this means, rectangular means we need x and y. Right now we have r and we have theta. So let's look at our conversions. Our conversions say that x equals r cosine theta and y equals r sine theta. So let's take a look at this. For my x-coordinate, r is 4, and I need to find the cosine of 5 pi over 6. And then for the y-coordinate, the y is going to be 4 times the sine of 5 pi over 6. So it looks like I need to draw this triangle so I can figure out what sine and cosine are there. So let's draw it. Give myself a little axis here. 5 pi over 6 is almost out here to pi. So it's out here. Go ahead and connect that there too. Alright, so if I've rotated 5 pi over 6, which is 150 degrees, that leaves me a 30-degree angle, and this is a 60, and this is a 90. So I'm going to label my sides. I'll put a 1 across from the 30. It's been a long time since we've done this, huh? I'll put a square root of 3 across from the 60, but it's negative because I'm going left. And then I'll put a 2 on the hypotenuse because of the Pythagorean theorem, or you know your 30, 60, 90. Alright, so my x equation is 4 times the cosine of this angle. We use our reference angle, so it's negative square root of 3 over 2. Adjacent over hypotenuse. So that is negative 2 radical 3 because the 2 canceled and we still had a 2 left. Now my y equation is 4 times the sine of 5 pi over 6. Sine is opposite over hypotenuse, so that's just 1/2. So my y coordinate is just 2. So here is my answer in rectangular coordinates. Negative 2 square roots of 3. I don't know why I put a comma there, so I'm going to erase that. I was already ready to do my y coordinate. Negative 2 square roots of 3, comma 2. So we've converted that into rectangular coordinates. That's an x and that's a y. Now let's go backwards. Let's convert to polar coordinates. So here I've got to go from an x and a y back to an r and a theta. So I'm going to draw this picture. Square root of 3, comma negative 1. Let me get back here and draw my triangle. I'll draw my dot first. Alright, so square root of 3x and negative 1y is out here at the square root of 3 and then down negative 1. Here is that dot. So what I'm going to do is I'm going to connect that dot back to the pole and I'm going to draw a triangle. So let's see if we can figure this out. What is the x-coordinate? Well, the x-coordinate is the square root of 3, so we went out square root of 3. The y-coordinate is negative 1. And if you do the Pythagorean theorem, you will get that this hypotenuse is a 2. So what we want to know is, what is the angle of rotation for our theta, and what circle did we go to? And that's our r. Here is our r. R works out to be 2. Now what is this angle? So I have a 30, 60, 90 triangle here because I've got a 1, 2, and a square root of 3. And I'm across from the negative 1, so this is a 30-degree angle. And we better use radians here. And I've got to use a positive angle from 0 to 2 pi. So that means we've gone around 330 degrees. Now in radians, this is 11 pi over 6. That is your theta. So my answer to this is r comma theta. So that's how you convert back. Now I have a challenge for you. This is the first time you guys have seen this, so I'm going to leave B and C blank here. And when you walk into class, I want you to tell me, what do you think the r and the theta are for these two? So if you can do those two, you know exactly how to convert back and forth. So hopefully we got those two things covered, and I will see you guys tomorrow.